All right, welcome back, ladies and gentlemen. Thank you. We had a wonderful lunch. I hope you did as well. And this is Kentucky Land of the EVs panel, really to talk about the new emerging technology of vehicle electrification and the role of the Commonwealth of Kentucky in this new and emerging technology. We have a great panel for you here today. We have myself, Jim Greenberger, followed by Bob Gaylen of Gaylen Energy, Steve Jahng of SK Battery America, Renata Arsenault of Ford Motor Company, Kim Menke of Toyota Motor North America, and Ken Srebnik of Envision AESC. The way we're going to work this panel is each of us are going to start with a short presentation, and then following that presentation, we will open the panel, which is really a panel of outstanding efforts in battery science and electric vehicles, to your questions, comments, and what other discussion will fill our panel time. I'm going to start us out. My name is Jim Greenberger. I am the Executive Director and founder of NAATBatt International. NAATBatt is the association in North America for advanced battery technology. We were organized in about 2007. We have about 250 corporate and research institution members today, and we have a number of activities that we've undertaken. Most recently, we've been designated by the U.S. Department of Energy as one of a number of organizations to facilitate a evolution of a strategy for the United States to develop a lithium-ion battery supply chain in North America, something we are sadly lacking here. But there is a history to NAATBatt which is pertinent to this particular meeting. NAATBatt, when it started in 2007, was not a trade association. We were originally formed to be a battery manufacturing consortium, a sort of a fab for batteries for American companies producing battery technology in North America to make sure we had battery makers in North America. We had the backing of, at that time, President Obama, and we looked to where we did a complete search throughout the nation as to where to set up this battery fab facility. And we talked to Governor Perry in Texas, we talked to Governor Granholm in Michigan, we talked to Oklahoma, South Carolina. But interestingly, the place that we determined after extensive study that the best place to have a battery manufacturing facility was in North America, given where customers were located, where the power was, where the transportation was this little village of Glendale in Hardin County, Kentucky. And that's where we decided to put the facility. Now, NAATBatt in its original form was ultimately not funded by the Department of Energy. Honestly, it was a great idea, but probably 10 years too early. But I am very, very happy to see now that that little village in Glendale, Kentucky, is exactly where the Ford and SK facility is going in now. And it warms my heart to drive down 65 and see all that earth-moving equipment there. So as Leo Tolstoy once said, God sees the truth, but waits. And I think that is true of the Commonwealth of Kentucky and electric vehicles. But the good news is that the wait is just about over. So I want to start out by taking an overview of just the global auto market and the United States' position in that market. You see that we have the second largest auto market in the world, at about 21% of all vehicles sold. China's a bit ahead. That's a fairly recent phenomenon. We'll see if that keeps up over time. But the U.S. is a major automotive market. The automotive market in the United States accounts for about 5% of our gross domestic product. It is the second largest employer of Americans after the healthcare industry. It is a really, really important part of the U.S. economy. So the question is, what implications does it have for the United States for this transition to electric vehicles? Because we really are in the midst of a technological transition from internal combustion engines to, at least in light vehicles, to electric power. So what's governing and what's driving this transition? There are really three things. First, our government mandates and incentives, which are really a function of concerns about climate change. And although that remains controversial here in North America, the fact of the matter is, in most of those other markets that I showed on my prior slide, it's not controversial anymore. Those markets are going full-fledged into pushing vehicle electrification through incentives and mandates. And the fact of the matter is, in the global economy we live today, even if it remains a controversial topic in North America, automakers here have worldwide platforms, and they're not going to be making different technologies in North America than they're selling in the rest of the world. So driver number one, we're being pushed towards electrification by government mandates and incentives, both in North America, but also around the world. Second, consumer preferences. The younger generation really does want to be environmentally sensitive, even if some of us older folks didn't grow up drinking that Kool-Aid. Everybody is drinking it now. And automakers know that, and they're responding to that, and that's driving vehicle electrification. The other thing is, just if you don't drive an electric vehicle, it's a wonderful driving experience. Once you drive one, you really don't want to go back. And if you don't believe in, you haven't driven one, just spend a little time behind the wheel of one. And the third, and I think most profound driver of vehicle electrification is technological change itself. Can I see the hands of everyone here who drives an electric vehicle now? Can you just raise your hand way up? Okay. All right, all right. Well, all you folks without hands raised, maybe you don't drive cars? It's, oh, I get it. You think you don't drive an electric vehicle. Well, you have power windows, you have heated seats, you have navigation systems. All these things didn't exist in cars 40 years ago, and yet all those things are causing the electric load of automobiles to increase and increase and increase to the point where you need a major power system on the car. Electric drive is really not a revolution. It's merely an evolution, a natural evolution of a prospect or something that's been going on in automotive technology for quite some time. The electrification of the drivetrain will occur just naturally as the evolution of technology goes forward. So what are the implications of this electrification of vehicles to the United States and the U.S. economy? Let's start out by doing a quick review of the supply chain for electric vehicles, really the supply chain for lithium-ion batteries, which are about 40 to 50% the value of an electric vehicle. You start with the raw materials you pull out of the earth, those get refined. They're put into cathode anode materials and other components of the cells. You have the cell formation itself. You have the module formation, which are strings of cells put together. Battery packs, which are a conglomeration of modules with a lot of electronic control components. They're put into a car, and then you have recycling. So where, with our 21% of the market, do we really stand in the United States as far as this next generation of battery technology? Well, obviously, we don't stand in a good place. This is the assembly of cells itself, which is really the base core technology of the electric battery. You see that China has almost 70%, assembles 70% of those in the world, and 8% are assembled here approximately in the United States. Most of those in this slide is maybe a year or so old, most of those by Tesla, which is really to say Panasonic. So we're way behind in cells. Maybe there's better news higher up in the supply chain with components and battery materials. But in fact, no, it's, the news there is even worse. We have anodes and cathode materials under 10%. Electrolyte barely negligible. It's what you need to transmit electrons from the cathode, the positive terminus, to the negative terminus in the battery. We make almost none of them. The electrolyte solutions, a little bit more, but still not much. And the separators, some participation, but nowhere near the, if you call it the fair share of what we would expect to see of the 20%, 1% of the vehicles we actually consume. So the result is that what we've got in North America today is really what I call the lithium-ion land rush. And this slide is actually a poor example. This only lists some of the larger projects going on today of largely foreign companies coming into North America to build in and build out the lithium-ion battery supply chain. There are a lot more projects going on than this. And this is fine and this is necessary because the fact of the matter is we really don't have yet the expertise in the United States to build this supply chain ourselves. We have to lean on our friends and our colleagues from overseas to come in and teach us, but we also critically have to learn. And educating that American workforce in this new, absolutely critical technology is something that is critically important. So what are our friends who are coming into North America to set up battery manufacturing plants and supply chain plants really looking for? This is what we are hearing as we're going out talking to them. Power, water, and gas being critical elements. Access to customers, again, the access to transportation, but also a very great interest in clustering, making sure that suppliers are located close to each other, something to think about as you're doing, helping people with site selection. A rational regulatory environment, access to a trained workforce. Trained workforce, that's really interesting because training the workforce before they actually go to work for the battery manufacturers who will teach them what they need to know, but educating them beforehand so that if that job doesn't work out, they can actually go out and get a better job or another job. They have some leverage to negotiate better wages. This is all critically important for the health of the U.S. economy and the well-being of those workers. Low carbon power is important. That's what a lot of foreign manufacturers are looking for, and that's something where we're a little bit behind our friends in Canada, for example, but something you should be aware of. And of course, the one thing we always hear, government officials who will be there for them when the rubber hits the road. It's one thing to go out and try to talk somebody into locating at a site in your jurisdiction, but to do that, you really have to convince them, and you need to work on convincing them that you're going to be there when there's really a problem. Now, what don't we want from foreign manufacturers? And I see my time's just about up. This is Morocco and Mexico, two of the larger auto markets from the standpoint of construction in the world. But you would not want to trade the U.S. auto industry for the Mexican or Moroccan auto industry because those countries really just assemble automobiles. There's no value add there. There's no R&D being done of any appreciable amount. There's no product creation being done. So it's a low value contribution to those economies. We have to make sure as we build out the lithium ion supply chain in North America that we're not just doing base assembly here. We've got to be doing more. So what do we want to be asking for from our friends who are coming to locate in the United States and the Commonwealth of Kentucky? That they think about localizing supply chains here. And tooling and equipment, which is really a subset of that. That's a critical factor that in order to make something, you got to be able to build it. We need to make sure that machine tooling and equipment in the United States somehow gets to be a part of this. Hiring local engineers, localization of research and development and product development, and most important, to become part of the community. Now, no one better than the Commonwealth of Kentucky knows how to do this better in the United States with foreign companies. Looking back to Toyota in the 80s and everything that's been done here, you can and should be a light unto the nation and to all the folks looking to come in to take advantage of this growing market here about how you can Americanize and domestic foreign companies and foreign technologies. And I wish you the best of luck in doing that. And again, I'd like to introduce the next speaker, Bob Gaylen.
Well, thank you, Jim. I'm going to try to hit 5 of those topics that you had on your prior slide. Been a very fortunate individual coming back from China 3 years ago as the Chief Technology Officer for the largest battery company in the world called CATL. I might say I might be guilty of helping put the operation in Glasgow that hasn't happened yet because of the geopolitical tension between U.S. and China, but that's not what I'm here for today. I'm here to help the Secretary grow the economy in the state of Kentucky, and I've got a bunch of slides here to help us get through that. So let's get started. So we have a few second delay in the slides, is that right? Yep. Are we there yet, guys? Okay, great. It keeps going back to the first slide. All right, let's go with this. Now I'm not seeing it up here, so I have to turn around and look at it. So let's go ahead and use these, I guess. Unfortunately, guys, if you can switch it over so I can see my slides up on the screen. Some interesting facts before I get into the details of what I really want to talk about, and that is that back in 2012, we had less than 120,000 electric vehicles on the road worldwide. Then, all of a sudden, mysteriously, in 2021, we had 6.6 million vehicles on the road with batteries in them, and those battery technologies are manifested in a variety of cars, but 3.3 million of them are actually made in China. So, as soon as I can get my slides back up here. Okay, guys, one more time. It's not working. I'm up there, but that's not my slides. Okay, let's try again. Let's try again. Here we go. Interesting facts. Now, here we go, finally. The cumulative end 2021, we had 16.5 million EVs on the road worldwide. And countries are phasing out ICEs. Predominantly here in the United States, you've heard many of the car companies that are in the process of phasing these out are finding that people are adopting electric vehicles at an astounding rate. One of the biggest concerns we have, and we'll talk about this a little bit later, is the charging infrastructure. There's 450 different EV models sold worldwide. That's quite a few different models. But all are falling short of the targets of hitting their zero emission target by the year 2050. That's unfortunate because that's part of the reason that I went to China to work in the first place, is take my skill sets to a place where we could make a big impact on worldwide ecology, because my degrees were in chemistry and biology and spent 46 years in engineering and international business. Now, EVs are predicted to be at 20% of all vehicles sold worldwide, at 20% by the year 2030. I'm not sure we're going to hit that target just yet. But being a good old Ball State University graduate, I used Dave Letterman's top 10 list. So I'm going to go through 10 of the most important things that this group needs to hear about over the next 7 to 8 minutes. First of all, remarkable growth. This is an astounding growth curve of roughly 34% of the economy is growing so rapidly. And I think the number of $300 billion investment over the next few years is not enough. I believe you're going to see something more on the order of $500 to $600 billion worldwide that's going to be put into electrification. Whoops, we're going too fast here. Bob, go back. Okay. Jim mentioned this a little while ago. Government engagement is really an important factor. What I'm finding, in fact, right after I finish speaking today, I go jump on an airplane and fly to Hungary for a presentation I give tomorrow at the Hungarian Battery Conference. And one of the things that the governments around the world are struggling with is what to do, how to do, and what to do, because they lack the knowledge. So many governments around the world, like our own, are asking for input. I was quite fortunate to sit on one of the Libridge committees, which is a group of people in the battery community that are making recommendations to our House and Senate on what legislation needs to be passed and what policies need to be put forward. And many of these countries around the world have that lack of knowledge and decision making. So it's up to senior leaders like the people that are sitting on the stage today to help them make those decisions. Another key factor in that top 10 list is, what are we going to use? What technology? Is it going to be an NMC technology? We use nickel, manganese, cobalt oxide cathodes, or is it going to be a lithium iron phosphate technology? For those non-chemists in the room, that's just the difference in materials that are used inside the battery. They have different energy densities. So making those in a certain chemistry is one thing, but what form factor to use? And the three predominant form factors that are made in batteries today are cylindrical, which are cheap, effective, very cost effective, and also have some of the best parameters as far as physical restraint characteristics. Pouch technology, which is a soft aluminum shell that requires a little bit more robust packaging that goes around it to make it work, but maximizes the packaging density, if you will. And then you got the prismatic, which is the one that we chose at CATL to make, because it really withstands the rigors of handling and shipping and transportation better than the other two in many regards. And it has the highest energy density, but the most difficult to manufacture. Now, this is one on infrastructure. Charging capacity deficiencies is going to be a reality. And I can't say it any better than Brett Hines, who's a Ford Motor Company person, did at the battery show last year. Brett made it very clear to the audience during his keynote speech that we must put and implement those charging stations out there at the same rate and time that we put the electric vehicles out there. Because if you get the charging infrastructure out too early, those companies will fail miserably. Or if you try to get them out there too late, then the people that are driving electric cars are going to be dissatisfied because they want to charge their electric cars so that they can get from point A to point B. Industrialization is a big deal. One of the primary reasons that CATL went after the brownfield plant down in Glasgow was it was readily available. It took us a little while to renovate and get it ready, and it's still sitting there ready. But most companies that are building battery plants have to build greenfield sites. These are very, very large factories. They are extremely high-tech plants. To give you an example, a 15 to 20 gigawatt hour factory will be approximately 40 to 44 acres under roof. That's a big factory. The big problem is there's not enough structural steel because right now we're competing between the car manufacturers, the battery manufacturers for that same steel. The lean-up concrete that they use for the walls is becoming short because there's only a limited number of factories that make those. And then the roofing materials is going to become extremely critical because of all the devastation that we just saw down in Sanibel, Fort Myers area. Every roof that I flew over the other day were ripped off. So there's going to be a big shortage of industrial roofing materials. And before, there were somewhere between 36 to 42 weeks of lead time in getting a roof material, maybe now a year or more. Another key area is fire concerns. You probably have heard about some fires with electric vehicles. That's something that we all up here on the stage are worried about. There's lots of companies out there working on mitigation technologies. I just picked on Hinkle because it was an available, easy one to grab off the internet. But Dow has it. Avery Dennison has it, 3M has it. They're all working on technologies to help mitigate and prevent fires and prevent propagation. Propagation is defined as moving fire from one cell to another. Those are the things that cause these rapid escalations in electric vehicle fires as well as energy storage. There's a lot of concern out there right now over this, and it's up to people like us that are on the stage to help prevent that from happening. Number 7 on the list is raw materials. Jim mentioned this just a few moments ago, and I'll have a couple more slides behind this one. But there's a real deficiency in making the raw materials here in the United States. I sat in a conference session with the Canadian government and the American government just last February, and we had a heated discussion over this topic. You can't make materials out of nothing. It has to either be dug out of the ground, harvested out of the ocean, and put in through a processing technology. The United States lacks both today, and this is one of the critical pinch points that we've got as a society. Most of those materials are lithium, nickel, cobalt, and manganese because they are the key materials, including graphite. As you saw in Jim's slide, graphite is one of the most important topics that we need to discuss, and it's one of the few things that we have here in the United States, but it isn't presently mined or processed properly to put into batteries. And one thing that came out of that conference at the Canadian Embassy back in February was the lack of mining. And most of the miners that were in the room said it takes approximately 10 years for us to establish a new mine, and particularly the lack of processing capacity. This slide shows a little bit more of the raw material situation. Most of the materials that we need for the United States are in politically risky areas of the world, less locations of sustainable value to the United States, and finding out that most of these geopolitical risks are just outweighing everything. Battery processing is more politically risky, as this is another slide that supports what Jim was saying a little while ago about where all the processing is occurring. You can look to the left, there's China. It's rearing its big head. Moving along here, recycling. I have to say I really admire Renata. She's the chairman of our battery recycling committee at NAATBatt International. I'm fortunate to be the CTO of that organization, and it's fun to work with Renata. One of the things that we did at the University of Michigan that Jim so graciously chaired a few weeks ago up at the University of Michigan was recycling is a big word. It includes those elements of collecting the battery packs back. It requires disassembly of those battery packs, separation of the materials, shipping them to the right locations for proper processing, shredding of those battery materials, and then reconstituting them through pyromedical or hydrometallurgical processing to reconstitute those rare materials that we have in those batteries. So recycling is going to be a major effort in the future, and we will see that happening within the next 5 to 7 years as we see larger quantities of batteries coming back. Corporate structure is another area. On the drive down here this morning, I was talking to a bunch of guys in the UK about corporate structures. What are we doing in the world? And you can see that two of the next speakers will be having a joint venture between them. Well, one thing that you recognize in joint ventures is it does a couple things. It gives the combination of both the battery manufacturer and the vehicle manufacturer leveraging in purchasing. They can order more quantities at a lower price point, which means it translates to a lower cost to you as consumers in the vehicles. This chart that you see up here is a corporate structure of many of the larger battery manufacturers. I put this in here so that you guys can go back and reference it later. I know I'm out of time here, but I've only got 2 more charts and we'll finish up. The new era of vertical integration and strategic partnerships is on this slide, so you can recognize the name badges of these different companies that are making the raw materials, the battery manufacturers that make the battery products, and finally the vehicle manufacturers that are using these batteries. And we're talking about large quantities of batteries. I know that last year CATL alone made 170 gigawatt hours. In 2 years they're predicting to make 580 gigawatt hours, so they're growing like crazy. It's just astounding numbers. And this is something you heard during our lunch hour time with our scientists that gave a great presentation. STEM education is so important. I'm working with Purdue University right now on how we educate and train those people working in internal combustion component companies today. How do we re-educate these people so that they can become electrified? So thank you for your time, and with that, I'll turn the podium over to our next speaker.
Good afternoon. My name is Stephen Jahng. I work at SK Battery America down in Georgia. We are the sole supplier for the Georgia plant for the F-150, as well as the Volkswagen ID4 being manufactured out of Chattanooga. Just to explain a little bit about, I'll be reverting back to workforce and infrastructure as well, but SK obviously is one of the key manufacturers of pouch-style battery cells in the world. As you know already, we are partnering with Ford to set up a facility in Glendale in Kentucky, as well as Stanton in Tennessee. The plant in Glendale in Kentucky is the largest plant that we are building. It's north of 80 gigawatt hours just out of Kentucky. Our Georgia plant is just above 20 gigawatt hours. It's 4 times the size of our Georgia plant. It is an enormous undertaking, and we're just very proud to be partnering with Ford Motor Company for the next generation of cars, as well as electric cars. Everywhere I stand and talk, I always revert back to workforce, because 5,000 people that we're gonna need to hire in Glendale just don't magically appear out of nowhere. And every discussion I have, I revert back to education. And the education for us needs to start at a K through 12 level, ultimately ending up in the university system. Where I want to start is that American society has changed considerably over the past 40 years, where the 4-year education has been at the forefront in front of every student going through our education system. But with this new age of advanced manufacturing that will be happening in Glendale, I think we need to start educating or giving skills to our high school kids from high school, even younger, to give them options upon graduation of high school. There is going to be plenty of good jobs. Our facility down along the joint venture facility with Louisville SK down in Glendale, it's a temperature, humidity controlled, dust-free environment. It is very simple. It's not the manufacturing that we are used to, that you're used to, that I'm used to, but it's a new environment. It's a safe, clean environment for our students and kids to work. So during high school, I believe STEM education, but mechatronics training skills, as well as advanced manufacturing, which is already available at the technical college level in Kentucky. If those basic skills are given to our kids, upon graduation, these kids will be given options to either work at hopefully ours and Ford's in Glendale, but will be given options to work at an advanced manufacturing facility, which I feel in 10 years, a good portion of the manufacturing will change. Once given that opportunity, if a student wants to continue their education, they could be directed to a technical college to further their education and or the four-year university system, at which point they will also be given an option to either work at a facility and or continue their education. If they want to continue their education beyond the four-year university and their bachelor's degree, they could be researchers. There's plenty. Our industry is changing. I don't see lithium-ion batteries disappearing anytime in the near future, but there is still plenty of research being done into lithium-ion, hydrogen, solid state, whatever it may be, and we still need a lot of students down that road. I will also touch on infrastructure because everywhere I speak, I get asked questions on range anxiety about EVs. It is not range anxiety. We can still make cars that go 1,000 miles on a charge, 2,000 miles on a charge. It's just a matter of economics and how much batteries you want to put underneath the car. It is more about infrastructure. It is more about charging stations. Without those charging stations, the EV industry has no hope because of the sheer fact that it needs to charge people. The range anxiety should not happen because currently it exists because there isn't enough infrastructure. I've heard a study coming out of California that the level 3 chargers are not really being used, which means that charging stations as a gas station may not work. I think charging stations need to be put in destinations where you actually park your car, rather than a charging station where you go to charge your car. I don't think it works, that system. And it's proved evident with the level 3 chargers in California not really being used. So I think generally the level 2 charging and the level 1 charging needs to be put in place. And hopefully we are going down the right road as DC is pushing that through right now, and hopefully once that infrastructure is put in place, and even rural America will have that infrastructure where EVs will predominantly be on the road. I don't own an EV at the moment. I own a hybrid. But ultimately, if you've ever been in a F-150 Lightning, it is an amazing piece of work. I hear there's one here today, but it is an amazing piece of work. If you ever get a chance to get in it, it's going to be faster than any sports car you've ever been in. Thank you.
Hello, everybody. My name is Renata Arsenault, and I'm with Ford Motor Company, and I work out of our Battery Center of Excellence. Okay, great. It's working. All right. So the first slide, I know you've seen this before in Bob's deck, but I thought it was very worthwhile to show one more time, to really highlight the exponential increase in demand for battery materials. And the numbers, those are not percent increases over the next decade. Those are like factors, like a lithium, 11 times, increase in just 10 years. So that's kind of a good segue into this topic of recycling and supply chain circularity. So if you look at the graph on the left, you'll see that very significant, and again, exponentially growing contributions to the input to the waste stream, or end-of-life batteries, retirements by sector. A huge chunk of those are coming from increasingly, the bottom is end-of-life batteries that will be retired, and I think that's like 2035-ish. And then another big chunk is battery manufacturing scrap, which is all the scrap that's coming out of all these gigafactories that are being built. On the right, on the graph on the right, you see two things. First, the vertical bars are showing the demand, but then the lines for the lithium, the nickel, and the cobalt are showing how much of these can be satisfied through recycling. And that's like a huge, you know, that's a great story, and particularly for cobalt. Now, cobalt, I think Bob touched on this. Cobalt is the one material, most of it comes from the Democratic Republic of Congo, and it's been associated with ethical concerns about how it's mined and you know, unfair labor practices, and because of this and because of its high cost, our industry has intentionally been moving toward chemistries with lower and lower cobalt. So our kind of relative need to the other materials is going down, and through recycling, we're going to be able to satisfy a significant portion of our cobalt demands, avoiding this mining sooner than the other materials. So that's a really great recycling story. This depicts our current reality, though, and our supply chain footprint is massive, sprawling. You get, you know, whether your lithium is coming from the salt flats of Chile or Australia, nickel comes from all over the place, cobalt, again, the DRC, but then most of it goes to China for refining, conversion into battery materials. Then it gets shipped somewhere else, again, typically for being built into cells, and then those cells end up, you know, being built into the batteries near the markets that they serve. But that's just unsustainable. And then again, just another graphic reiterating a point that was made by Bob. The majority of these materials are refined today in China, and China has really seized a strategic advantage in really kind of dominating this midstream market segment. So this visualization from Visual Capitalist, I think, beautifully illustrates why the battery is considered today as a valuable urban mine. So in other words, the battery, even though these materials are mined, you know, all over the place, but once they're in the battery, they contain all the materials that you want to put in new battery cells. So we would be foolish not to, you know, exploit that and recycle them. And then look at the quantities of these things that are in, and this is this example uses a 60 kilowatt hour battery, which is really small by today's standards. And look at the staggering quantities of these precious materials that are in there. So really, recycling affords sustainably sourced, low carbon materials for our supply chain. So this is the complex battery life cycle, and you know, it goes through many phases, but the point I'd like to make on this slide is, if you see the little circle, you know, recycling down near the bottom left, for OEMs such as Ford and Toyota, we're concerned at both the input and the output of that circle. And then increasingly, through these collaborations and joint ventures, we're kind of now, you know, starting to get involved in all of those life cycle points or phases. But coming in, of course, we need to be responsible stewards for the technology that we put out on the market. But coming out of that recycling, we want to work with our supply chain to ensure that what is removed, recovered from our batteries, goes right back into our supply chain. Okay. Uh-oh. I don't know if there's a delay. Okay, there we go. All right, so I'm going to try to make this brief, but you know, since we had Mr. Science here, we're we're going to go through, because we've been talking a lot about circular economy, but I wanted to sort of convey what that means for EV batteries and battery recycling with kind of a crash course on battery recycling and chemistry 101. So the first thing that happens, the batteries that come either from end of life or from manufacturing scrap from our factories get converted to black mass, this stuff that you'll probably be hearing more and more about, which contains the anode powder, the cathode powder, that's sort of like what makes the magic happen in a battery, and some impurities. So that then goes to another facility where it's converted. This is just kind of an example, progression. Other variations are possible. But then it would go to a hydrometallurgical facility where it's converted to battery-grade metal sulfates and lithium compounds. Next, it would go to a precursor manufacturing facility. And precursor, so one thing I forgot to mention, the cathode, which we've been hearing a lot about, nickel, cobalt, manganese, lithium, those all mostly reside in the cathode. And the cathode that is sort of the workhorse chemistry for most OEMs, or many OEMs, Ford, for example, is a material called NMC. So the N, the M, the C stand for nickel, manganese, cobalt, and the lithium is in there too. So the precursor is basically a highly engineered material that's the NMC but without the lithium, and then the next step is conversion to the cathode where the lithium is added. Then the material is ready to go into cell manufacturing. So this is kind of several stages, but each of these represent massive hundreds of millions of dollars of investment, infrastructure, permitting. So this is not a trivial little thing to put up, and each one has unique considerations in terms of what's important, resource requirements, effluent minimization considerations. So there's a lot of investment required to build this whole supply chain out, but you can imagine that if you don't have, so today we're starting to have black mass and we're putting up the next box, metal sulfates, but if you don't have the next ones going down the line, then you're going to be shipping your battery materials that you've recovered offshore until you have each segment in place. So that's kind of a critical point to make. And okay. Oh, right, and I forgot to, oopsie, wonder if I can go back. No. Okay, well, my last slide was just showing that depending on the recycler, yes, that each recycling process doesn't necessarily get introduced back into that supply chain in the same form. So some recyclers just make black mass, others add more value and make metal sulfates, others go to the precursor or even cathode level. So that's not all recycling is the same. We've obviously committed at Ford. We're all in on this electrification revolution. We've committed to run rates of 600,000 EVs by the end of 2023, 2 million by the end of 2026. And this requires, of course, this requires a lot of technical criteria to be in place. Performance, design, affordability, safety. We have to capacitize, to be able to produce all that, but also front and center as we, kind of unveil and roll out the infrastructure for all this. ESG is really front and center, and it's the lens through which we make all our decisions related to the supply chain, our own and that of our suppliers. So I think that's really critical. And then recycling, closing the loop again, almost done, will happen in stages. So the first thing that will occur, today we saw our sprawling footprint and stuff being shipped all over the globe multiple times, just because we're lacking some of these segments, everywhere. So the first thing that'll happen in probably a decade is we'll be able to close the loop through recycling in each region, but we'll still be having to remove things from the ground to satisfy our demand for the materials as we transition from ICE to battery-powered mobility. And then probably somewhere in the middle of the century, we'll be able to enjoy fully circular economies in each, battery supply chains in each region. So most of the materials going into the new cells will be coming truly from recycling as opposed to mining. And then I think this is just, the obvious: battery recycling, sustainability, stewardship, securing critical conflict-free materials for our supply chain. And the beautiful thing is that as we ramp up and come to scale, it will also provide economical benefits both for the industry and for our customers. So the final image is just beautiful recycled materials from batteries. So.
Well, good afternoon. As the original environmental engineer for the TMMK plant, the Toyota plant in Georgetown plant over 35 years ago, I've got the honor and pleasure of being back here participating in the annual Governor's Environmental Conference, and it's got my engineering juices flowing again. It's been great to hear what's going on here. And I've got the pleasure of talking about the next big thing that's coming to Kentucky: electrification, through sustainable carbon neutrality through electrification. Toyota's philosophy and motivation, to do this is the same today as it was 35 years ago when we started the plant. It's offering the best technologies available in our plants and in our products, and setting goals that go well beyond the regulations or the standards to be a good neighbor and to create the net positive impact on the planet and society as a whole. Toyota's 2050 environmental challenge of reducing CO2 emissions by more than 90% is that motivator that gets us going, and it's driven us to consider lots of strategies to be able to get to that will allow our customers to choose which carbon-reducing technologies that suit their circumstances in the short term, and provide more carbon-neutral technologies as they evolve and as infrastructure becomes available to be able to truly meet carbon neutrality in the future. So we've taken the approach of, it's a portfolio. Everybody is making changes and needs to make changes based on their needs and for their vehicles. And so we take an all-of-the-above approach. We have hybrid electrics, we have now plug-in hybrids, we have battery electric vehicles, and we also have fuel cell vehicles. And I was really pleased to hear so much conversation around hydrogen as well as plug-in technologies, because it takes both. And when we look at what the current real goal is how do we reduce carbon? And so when you look at the entire life cycle, hydrogen is really the best answer in our view. When we look at the current requirements that Jim mentioned as well, we have a requirement now of 50% of the vehicles sold by 2030 have to be electrified. Now that puts OEMs in the middle. Obviously you have to have a willing seller, but you also have to have a willing buyer. And that's the big catch. And so we need to provide the education and help our customers understand, be able to afford, and ultimately adopt these technologies to have a real impact on the environment with the necessary supporting infrastructure. And as we transition away from the dependence on the internal combustion engine, it all just takes time. So electrification is nothing new at Toyota. I can remember back in the late 90s at the plant, I actually had a plug-in RAV4 that we developed for fleet sales out in California for about 6 years in the late 90s and the early 2000s. It worked pretty good when it was warm, but when we got into Kentucky winter, I could only go about 20 minutes out and then I was walking back. So we had to evolve the technologies. And so we've learned from that. In 1999, we introduced the first hybrid. Again, how do you electrify and make it better? You know, that's one of the principles of Toyota. How do we always improve on what's going on? And so we launched that Prius. You know, it took off great in California, but across the country, maybe not so well because it was new. There's a learning curve here. In 2006, we actually launched the first hybrid in the US with the Camry in Georgetown, Kentucky. And we've been building hybrids ever since. Everything that we build at the plant in Georgetown has a hybrid component. So you have a choice. We currently have 21 hybrid vehicles that we offer, from compact sedans to large premium sedans. Minivans, the new Sienna, you can only get in a hybrid now. And trucks. We now have the Tundra, that's a hybrid. And so you have this broad range to be able to meet the needs that you have for the things you like to do. We expect to expand that offering to over 70 vehicles by 2025. To date, we've sold more than 5.4 million electrified vehicles in the US. Today's portfolio includes plug-in hybrids that give you that pure electric option for short trips, so you have a smaller battery. And then if you need to go that extra distance, you have that gas engine to be able to kick in so that you don't have that range anxiety. So it makes the best utilization of a battery, so you don't have this huge battery that you only use this much of. You're truly utilizing the capability of what you have and getting the best return on investment for the environment. You can see we also have a full electric now with the BZ4X crossover. Up in the right corner, you see the hydrogen fuel cell. That's the Mirai. We've been actually producing that for quite some time now in California. We've got over 10,000 of them on the road. California also has an infrastructure for the Mirai of over 25 fueling stations that allow you to be able to refuel that vehicle. It's very similar to a gas station. It takes you about 5 minutes to fill your hydrogen tank. And I think you probably all know how the chemistry works, since we've been talking about that all day today. The bonus that the folks in California found with the Mirai is it not only generates electricity, but it also cleans the air up that it takes in to drive the reaction. So it's a pollution control device in California. But it doesn't just stop with passenger vehicles and cars and trucks. We've taken the fuel cell technology and actually proved it with a partnership that we had back in 2017. We started a pilot project with PACCAR, the California Air Resources Board, and the ports of Long Beach and LA, where they were utilizing 2 Mirai fuel cell stacks combined together into a Class 8 truck. So whether it was the yard truck that moves around the sea containers that come in and out of the ports, or their forklifts, or the out and back trucks that actually transport the products to their destination, we were able to prove that fuel cell is a viable opportunity for freight movement and with 0 emissions. Toyota is always improving and evolving as a mobility company. TMMK has been in production for 33 years with a facility investment of over $12 billion. We're always reinventing. As I said, in 2006, we debuted the first hybrid. And as was mentioned earlier today, last year we announced a $461 million expansion to be able to retrofit the existing facility to be able to not only build sedans, which is what TMMK was originally set up to build, but now we have the capability of building any type of vehicle, any technology type of vehicle, based on what the customer will accept and will use. So we're in preparation now. We don't have a product yet, but we're bidding for the next new technology vehicle that Toyota will launch right here in Kentucky. But we've got to work with our other Toyota facilities. They're competing for it as well. Part of the other announcement that we had during that $461 million was the introduction of fuel cell module assembly. So Kentucky, we will actually build fuel cell modules here in Georgetown for Class 8 trucks that will begin in 2023. We have a partnership with Hino, who's a sister company to Toyota. They're based in Arkansas and West Virginia, and also with Kenworth or PACCAR. And we anticipate those sales going through the roof once the infrastructure is built. Again, you got to have both, and they have to be timed correctly, as was already mentioned. But fuel cell technology has a lot of additional opportunities for growth. It could go into rail, it can go into maritime, it can go into aviation, as well as stationary backups. So you think about all the potential opportunities there, again, with the environmental benefits of zero emissions. In our 35-year history in Kentucky, change has always been constant. And so we're always looking at how do we continue to improve. And so we have now kicked off Transform TMMK. I've talked a little bit about the plant changes that we've made. I've talked about the products that we've made, and we're also improving our people. So how do we deal with the new mindset for workers and workforce? Again, focusing on the same things that Steve was talking about. And just to wrap things up, I want to take a moment to thank the Kentucky Energy and Environment Cabinet and the Transportation Cabinet for their leadership in developing not only the EV infrastructure deployment plan, but also coordinating with the surrounding states on the National Electric Vehicle Infrastructure Plan to establish not only electric charging stations, but interstate hydrogen hub corridors. And I support plants around this state, so I have got surrounding states as well. And Kenya Stump has been leading the charge and is the premier leader in getting folks to really think dark and deep about how do we connect, because we're all in it together. So my hat's off to the cabinets and their leadership for their support in this activity, and it's really proud to be able to say that Kentucky is leading the way in EV technology. Thank you very much.
So it was after lunch, and I'm the last of six. I'll be quick, as most of the headlines were already taken. But let me reinforce a few things you've already heard. First of all, to give you a little background, my name is Ken Srebnik. I'm here as part of Envision AESC, which is a EV battery manufacturing company, a global company. My previous life, where I met Jim about a decade ago, was with Nissan with the launch of the Leaf, which, whether it feels like it or not, was 12 years ago. Actually, this month is the 10th anniversary of our plant in Smyrna, Tennessee, that Envision now owns. And also, mostly my wife, but she lets me use it sometimes. We've been an EV driver for just about that whole decade also. So it's definitely, we have a sneak peek to some of the questions coming up. We're definitely past that tipping point or at that tipping point. It's a very different environment than when we would go to these conferences in 2010, 2012, and so on. So we're very excited to be here. We're proud to be part of Kentucky's Land of EV. I'll share some details on that in a little bit. What I wanted to do was introduce Envision to you. You most likely have not heard of it, but we have a very large global reach and are very much part of this whole electric vehicle movement. Green, I don't see green. Okay, so we are part of a large global company called Envision Group. It's the world's a world-leading green tech company. Everything that it sets out to do is around sustainability commitments, clean energy commitments. Some of the key areas are one of the largest smart wind turbine and energy storage companies called Envision Energy. We are Envision AESC, making the batteries, and then through Envision Digital, another separate company, the world's largest AIoT, so artificial intelligence, Internet of Things, to help systems run themselves and run as efficiently as possible. On the fund side, we also have a $1 billion capital fund for net zero investments, projects and investments, and we own a racing team in Formula E. So just to, I won't go through all this, but you see the global reach. For Envision AESC specifically, we now have plants in the US, in the UK. We have plants being built both in France and in Europe, in Spain. We have plants in Japan, and we have plants in China. We are a Japanese headquartered company using Japanese-developed technology and IP with a very diverse executive force helping to run the company. True to our commitment around sustainability, we were ranked in 2019 by MIT Technology Review as one of the 50 smartest companies. And in 2021, we were ranked #2 on Fortune's Global Change the World list for the role we play to help achieve net zero emissions. What we have publicly committed to is being carbon neutral in our operations this year. We will make it. And by 2028 to achieve carbon neutrality in our entire supply chain. So lofty goals, but we are putting the resources behind achieving these. So we have over a decade of experience. The company's history goes back to Nissan and NEC, a partnership that was made when Nissan was planning to come out with the Leaf, the first mass market EV. There were no battery companies to choose from. There was not many in the industry that could supply, so they started their own with NEC. That was started back in 2007, 2008. The first Leaf came out in 2010. U.S. production in Smyrna, Tennessee started in 2012, shortly after UK production, and things continued along very well. Around 2018, Nissan decided they needed to devote the appropriate resources to both the car and the battery. They couldn't, they chose the car. And that's when Envision came and bought out their interest and renamed us to Envision AESC. So the exciting news since that chart, this past April, and our connection to Kentucky and our excitement about being here, a partnership was announced with Mercedes-Benz. So we have broke ground on a facility in Bowling Green, Kentucky. This was, it's an investment fully from our side. That was the second largest investment in the state of Kentucky history. Some on the podium here might have been the biggest one, but we'll take number 2. But we're looking at a $2 billion investment and up to 2,000 employees as we get to start of production. What we're very proud about, our product, the battery, we are categorized as a global tier 1 battery manufacturer. We have the history of the engineering from Japan that went into our earliest batteries and production of it. For Nissan, we're very competitive on pricing, and you balance pricing, as they said before up here, with range. And also, the thing that we really highlight is in 12 years, over 650,000 batteries and EVs that came off our production lines, we've had 0 critical accident issues. There's not been any thermal incidents or quality issues with our batteries that are out there. Where are we going? So again, this is for AESC. We have a plan to get to 300 gigawatt hours of capacity by 2025 and be 100% zero carbon operation. In Japan, we're at about 3 gigawatt hour today. Our plant in Smyrna is at 3. UK right now is about 2. New facility being completed, going up to about 25 to 60, depending on the nominations that we get from various OEMs. And in China right now, about 20 gigawatt hours. With the new plant in Bowling Green, adding another 30 to 40. Talked about the UK. A new plant in Spain being built as part of a government program there, 30 gigawatt hours. France, tied to relationship with Renault, with flexibility from 24 up to 60 gigawatt hours. And then both our plant in Japan is being expanded, as well as several in China. And these are all investments of the company. We own these plants. We work closely with governments. We have a very good relationship with the state of Kentucky, and we're very pleased, not just from the incentive side, but I think something that was touched on, the quality of the workforce. I mean, that is the big need, is finding all these skilled workers. And we were made aware and have witnessed several programs they have starting as young as 7th and 8th grade, just to give exposure to the students and help them understand viable career paths within here. Just a quick look, in Smyrna, as I said, right now it's 3 gigawatt hours. There's plans and flexibility to more than quadruple that. And again, we're going to hit our 100% renewable energy objective this year. I believe the governor was here yesterday. You might recognize him. This was at our announcement event for our investment. So again, we're very, very excited to be part of Bowling Green and Warren County and the whole team Kentucky as we move forward. We're scraping the land, we're starting construction, we're finding good old Kentucky sinkholes, but we expect to start having some operations as early as next October. This is not a true picture of it, but placeholder for Bowling Green. Again, capacity there will be 30 to 40 gigawatt hours. It will also be 100% renewable energy, as I said, in 2025. And that's it, just an overview of Envision, and gratitude to Kentucky for including us today, as well as everything else that we've been working on together, and very excited about the EV industry. Having been on the OEM side and now the battery side, there's no stopping. I wouldn't even say it's the wave of the future. I'd say it's the wave of today. And if you haven't driven one, that's all it takes. Just get in one. Because the best thing about an EV is the way it drives. So, thank you.
By my watch, I think we have time for one question. No, one question. All right. I got a scowl, but a good scowl. All right, and we're going to go with the top-rated question from the audience. Where is the funding for education, particularly, I think, at the high school level, and is there any in the Infrastructure Act? Does anyone know the answer to that offhand? Anyone want to jump in? I will tell you what I have seen. I don't know of any funding for high school education in the Infrastructure Act. There's a fair amount of money being put out by the federal government, by state and local governments for training generally, although most of that money, I believe, is going to be targeted to universities and, more importantly, to community colleges to train technicians. In fact, one of the problems we found at LIBridge, which is this initiative I've been involved with, is that there's so many people trying to put training dollars out that nobody really knows where all the money is and what it's going to. There's really no coordination with it yet. We're hoping to sort of address that as part of the larger strategy. But that was sort of the, my answer. I don't know of anything specifically going to high schools, but that's actually a very good idea.
I would just add that Governor Beshear has developed a program where any high school senior in the next couple of years in Kentucky, should they want a job, can be funneled into the training system that's now being developed. Now, he's announced that. I think I'm not in the workforce development cabinet, so I don't know where that stands right now, but it's a great opportunity, I think, if we can get that off the ground.
Well, that sounds like a great program. Well, please join me in thanking our panelists, and I think we go to a break now. Thanks.